Hey guys, today we're going to learn the last way that we can factor, and that is factoring by grouping. So let's take a look at this flow chart real quick for a second here. So first off, to factor, the first thing that we're always going to do is we are going to first and foremost look for a GCF. So we need to do that first on every single problem, just like what we did yesterday. And then, if there are two terms like there were yesterday, that's where we can do difference of squares, which is a squared minus b squared, or sum or difference of cubes, which we got to practice yesterday. Now, something we've done in the past, if there are three terms, we can look for the x and the plus sign like this. We draw our x, and we go, remember that is where we have ax squared plus bx plus c, right? That's when we're factoring a trinomial. And so whenever we do that, we can draw our x with a times c on top, b on bottom, and my two numbers that multiply the top and add to the bottom. Or we can do our plus sign, which is going to have ax, and our two numbers. Now, we've gotten a lot of practice doing this. We're going to get just a smidge more practice doing that today. But our new way, the new way that we can factor is by factoring by grouping. Now, I like to call this like double GCF or pulling out two GCFs or whatever. That's kind of what we're doing. So if we take a look at this, come down here and take a look at number one. Okay? Oh, sorry, I forgot the last bit. Then make sure that you can check and that nothing else can be factored, because remember, sometimes when you factor difference of squares, it can factor again. All right, now let's take a look at number one. So number one, it says factor and find the zeros for this. And you'll notice, first off, we look for a GCF. So we look for a GCF between all of these. And we can see that on this problem, there is no GCF. All right, then we're going to try to factor by what's called grouping. Now, factoring by grouping, I think, is a really ingenious and easy way to factor, and it kind of works like this. So let me rewrite out this polynomial. We have x cubed plus 3x squared minus 9x minus 27. Okay, this is our polynomial. And the way we factor by grouping is what we're going to do is we are going to group the first two numbers together and the last two numbers together. And we're going to find the GCFs of the first two numbers and the last two numbers. Okay, so here's what we're going to do. We're going to group these two numbers together and these two numbers together. Go ahead and include that negative in there as well. That's important. Okay? All right. Now, we're going to look at these first two numbers. I'm thinking, okay, what is the GCF of these first two numbers? Well, they don't have any whole numbers in common, but they do have an x squared in common. They both have more than two x's multiplied together. So here's what I can do. I can divide both of these by x squared and pull an x squared out to the front. So I can make it x squared times x plus 3. Okay? See how I pulled out the GCF of my first two? And then we're going to look at my last two, and I'm going to pull out the GCF of my last two. All right? And my GCF of the last two, let's see here. They don't have any x's in common, but they do have a 9 in common. However, I want you to notice we do not want our first little bit to be negative, even if we're finding the GCF of these two little numbers. So what we're going to do instead is we are going to pull out a negative 9, because negative 9 goes in both of them. So we're going to divide this by negative 9, pull out a negative 9. So we'll pull out a negative 9 out in front, and that's going to leave me with x plus 3. Okay? All right. So here's the deal. This x plus 3, check it out. This x plus 3, we now have two terms. We started with 4 terms, but I've created now 2 terms. I have this term and this term. And you'll notice we can now find the greatest common factor of these two terms. I can pull out what they have in common. They both have an x plus 3 in common. So I can pull out to the front x plus 3 and multiply that by x squared minus 9. Okay? So we're going to pull out an x plus 3 because after we pull out our GCF the first time, we get x plus 3 in common. We can pull out that x plus 3 to the front, and that leaves me with x squared minus 9. So we get the factors x plus 3 times x squared minus 9. So we have successfully factored by grouping. But then we need to check that nothing else can be factored. And unfortunately, we see one that can be factored, this x squared minus 9. That x squared minus 9 is a difference of squares. So I can rewrite that x squared minus 9 like this. We can change it to be x plus 3 times x plus 3 times x minus 3. Okay? So we fully factor it out. This x squared minus 9 changes to this. So, and the way it does that is, remember, if we have a difference of squares, if we have x squared minus 9, right, that's saying that's x squared minus 3 squared. So this is my a, this is my b. So I can write it out as, remember, it's a plus b times a minus b. So that's how we can write it out as x plus 3 times x minus 3, like that. Okay? So my factors are going to be x plus 3 times x plus 3 times x minus 3. We could write this instead as x plus 3 squared, but it doesn't hurt it to write it out either. All right, now my zeros. Now remember how we find our zeros. We set my factors equal to 0, right? So if I took x plus 3 and set that equal to 0, I would get an answer of x equals negative 3. And if I set x minus 3 equal to 0, I would get the answer of x equals 3. So my zeros are this, x equals negative 3 and x equals positive 3. All right, let's move on to number 2. Number 2, we're going to factor this guy out as well. All right, so to factor out number 2 here, we're first going to need to look for a GCF. And in this case, we do have a GCF. My GCF is going to be, well, we don't want that negative in front, so we need to pull out that negative. But each one of these also has an x, with the lowest one just having 1. So I can pull out an x. So we're going to divide each one of these by x. And we're going to make it a negative to pull out that negative in front. So we're going to divide each one of these by negative x. All right, so check this out. It's going to be a negative x in front times x to the third plus x squared minus 9x minus 9. Then we are going to factor by grouping. After we pull out a GCF, we're going to look and we're going to see, hey, I have 4 terms, so I can factor by grouping. So I'm going to group the first 2 together like this. I'm going to group the last 2 together like this. We're going to factor out, kind of ignore this negative x, we'll bring it back down, we'll put it back down over here. But we're going to factor out here, these 2 have an x squared in common. Okay, these 2 have an x squared in common, so I'm going to pull out an x squared of the first one, and I'm going to pull out an x squared of the second one. So we'll have an x squared in front times what's left over is x plus 1. And then in my second problem here, both these have a negative 9 in common, so we can pull out a negative 9. So we'll pull out a negative 9 here, and that'll leave me with x plus 1 on the inside. Okay, now I have an x plus 1 in common between these two. Just pull that to the front. and these two numbers go together, okay? So after we pull them out, if these two match, they just go together, they squeeze together, and we just put our x squared minus 9 together. So we're going to have x plus 1 in front times x squared minus 9, and I cannot forget about that negative x out in front. Okay, now, x squared minus 9, I can still factor that. X squared minus 9, remember, that's the same thing as saying x plus 3 times x minus 3. Heck, we just did that on our last problem, right? Okay. So, here are all the factors, all right? Here are all the factors, and we can list those out here. We have negative x, that's a factor. X plus 1 is a factor. X plus 3 is a factor. And x minus 3 is a factor. I cannot factor it anymore. But what does that mean my solutions are? Well, my solutions are if we take each factor and set each factor equal to 0. So if I go negative x equals 0, hey, x equals 0. So there's a solution. X equals 0. If I take x plus 1, that means x equals negative 1. So x equals negative 1, and if I set x plus 3 equals 0, that means x equals negative 3. Need to give myself a bit more space. And then if x minus 3 equals 0, that means x equals positive 3. All right, so here are all my factors. Here are all the solutions, okay? So that's how we find our factors and find our solutions. All right, let's do one more together. All right, number 3. We're going to factor this one by grouping. Now, this one, you'll notice, does not have a GCF. So we're going to start off with that. We're going to say it has no GCF. And we're going to group, there's 4 terms, so we're going to group the first 2 together and the last 2 together. I actually should have gotten that plus in there too. All right. So, first 2 together, last 2 together. I'm going to pull out a GCF of the first 2. So we're going to pull out a 3x squared, right? That's my GCF for the first 2. 3x squared. All right, so we'll have a 3x squared out in front times 3x squared divided by 3x squared is x. 18x squared divided by 3x squared is 6. So we'll have x plus 6. All right, then my other one will have an 8 in common. So I can divide the first one by 8, divide the second one by 8. And we should get plus 8 times x plus 6, right? Because we were able to divide both those by 8, and 8 divided by 8 is x, 48 divided by 8 is 6. Okay, so then, you'll notice, once again, I have an x plus 6 in common. So that x plus 6, I can just factor that out. I can move that to the front, right? So, we're just going to factor out the thing they have in common, factor out the x plus 6, and that's going to leave a 3x squared and an 8 that can then go together. Okay, so that is how you factor by grouping. Now we check and see, can I factor it anymore? Well, 3x squared plus 8 is not a perfect square anymore. So once we check that out, we just leave it there. Okay, so this is my factored out answer. All right, last one we're going to do together is number 4. We'll go over 5 and 6 tomorrow, but I wanted to remind you how to do number 4 a little bit. So number 4, we have x cubed minus 4x squared minus 5x. So what we can do is first we look for a GCF, and the GCF on this one is x. So we can come in here, divide each one of these by x, and we're going to get x out in front times x squared minus 4x minus 5, and now we can factor out that x squared. We can label my a, b, and c. So this is a trinomial. So remember with a trinomial, we solve trinomials by doing x and plus. That's how we factor. just like we did a while back. So let's label my A, B, and C. My A is 1, my B is -4, my C is -5. So over here we're going to go A times C on top, B on bottom. So 1 times -5 on top, -5. B on bottom, -4. Two numbers that multiply -5 but adds -4 is obviously -5, -5, and 1. So put those numbers down here. Write my 1x, so those are my factors. X minus 5 times x plus 1 with my GCF of an x out in front. Okay? All right, guys. Hope this has been of help to you. Please, as always, let me know if you have any questions.